Ant Army members, and welcome. This is probably one of the most exciting streams because we have come to the end of our journey that we started quite a while back, and that is to answer the age-old question of, did whoever really smelt it, were they the one who really dealt it? Well, I definitely answered this. And of course, the answer might just apply to me and my, family situation. We do have a culprit that always ruins movie nights. When we have guests over, it's quite embarrassing because everybody looks at the humans first. But if you caught the video I put together, we all know it wasn't any of us. It was actually my four-legged little furry friend Eeyore, my little shop helper here. So finally, I found out that the one who smelt it was indeed not the one who dealt it. Like, not at all. So I was happy to be able to clear my name, because it was in the mud there for a while. So with FART-A-TUCHUS, this was a really fun project, and I really liked all of your guys' comments on where you think it was going, all of your ideas for the features and the detection features that it should have. How do we hide the device? Should we have it in plain sight, like a big old meter that we carry around? Or do we hide it in something kind of like ordinary every day? And that's where I came up with this. Now, some of you, as I move around, might have seen, a couple little things behind me, two little cats. Well, it turns out that I had quite a few victim options when I started looking. But with FART-A-TUCHUS here, he was, or this buffalo bison thing, he was probably the best bet because he was the largest. Those two right here are kind of small. So for him, I know I'd be able to fit whatever it is that we came up with, all in him. So I know we've seen bits and pieces together. We actually prototyped this on an Arduino board and a breadboard to get the LED lights working, to get the sensor working, and then finally I added a servo. We looked at the code, and a lot's progressed since then. So before we progress though, let's go back and see how this whole thing even started. So to start, well, it's surgery time. And for that, I needed to perform a stuffectomy. Yeah, we needed to kind of hollow him out. And so looking at him, I wanted to do this the most natural way possible. And that's to use just the existing seam lines. And I figured if I can tear at those and just remove the threads, well, I'd be able to put it back together again, concealed, and no one would be the wiser. So of course, with every stuffed animal, we have discovered the beanbag butt. This is the part that makes them sit nice and upright. And in the beginning, I thought about keeping this beanbag butt. So I put it aside, but eventually, we'll see together if I wound up using it. And holy grail of stuffing. Now, I understand this is kind of disturbing because watching it now, I'm like, kind of reminds me a little bit of the, it puts the lotion in the basket a little bit. So, a little freaky there. But at this time, I didn't really know how much I needed to hollow him out. I figured, you know what? I think I'm going to leave a little bit of fur in his face and his head and maybe a little bit on his feet right here, and then figure out, I could always hollow him out more. But I definitely knew that I would need to do something with the eyes, and then I was going to try and animate his nose. So I had to just kind of like, remove some of the stuffing there. And this poor guy didn't have any eyes because Eeyore, who we found out was guilty of all this, was the one who chewed his eyes out. So it was like he was trying to sabotage the project before it even began. So perhaps I didn't even really need to do this because, he kind of like made himself pretty guilty right there. So with him, we have the skin hollowed out, ready to go. And now to try and figure out like how to build something, because you can't just stick like a servo or moving parts inside a stuffed animal, because as that servo moves, the head is just gonna like move around. It's not gonna have any form. So we almost have to build like this skeleton for it, like this endoskeleton. So I figured, all right, let's try and do that. And I had no idea how I was going to start this. So I figured I'd start with the head and just kind of build as I go. Like everything here, we very rarely start or stop with any plans. But you know what? I keep getting rewarded. Things keep working out for whatever reason. So here I am, and I figured first thing I have to do is figure out how to mount this servo. So I took a piece of scrap wood and started cutting out like a square for it. And this is looking a little mangled here, but let's see if I can clean this up a little bit. Doesn't matter too much. No one's gonna see it, but I know. I'll see it. So in the end, a little bit of sanding, we ended up with like a nice rectangle where the servo fits in. Maybe a little wiggly, but mostly working out well there. And for the servo, it needs to anchor in or screw in. So here I am creating like a backing panel where the top of the servo can be screwed in. Now the servo is like fatter than this piece. So you see me here, I'm preparing to add some spacers in order to lift the next piece that I'm gonna put on. So that way the screw has somewhere to attach itself to, because right now it's just kind of like floating up in the air if I were to attach it. But it turns out that it was advantageous to do this because look at that wire. It's nice that the servo kind of protruded out a little bit because that wire didn't get pinched at all. And am I hammering like right down on the servo and nails? Oh my gosh. This is the part where I hope there's like no woodworkers watching because they're just like, I can't unsee it. Oh, it's horrible, horrible woodworking. But that last part that you saw there was what I was thinking for the nose and attaching the nose portion, which is a popsicle stick, to the servo and then having it go back and forth. Eventually I did double up on that not toothpick, but popsicle stick because I was afraid that it would break. I didn't really know how it would handle this fabric. The fabric's not all that thick, but it does have some stuffing still. So I figured, better safe than sorry. And what I also did is stick glue all around that toothpick too, just in case it cracks. Because popsicle sticks crack really easy, as I soon found out that, those popsicle stick crafts, stay away from them. They're just like a pain because they just fall apart. So next we have the servo. So we have the workings kind of a nose, and now I have to figure out this eyeball situation here. So this is how I went about doing it. So again, taking just scrap pieces of wood and cutting them down. I'm sticking like, I guess what's called ears, but think of it more of like eye attachments. They kind of look like ears for now. And sometimes there's just no good way of clamping these things down. And so a lot of holding things with the fingers and waiting for it to at least tacky up enough so that way I could clamp it down. So this is not as bad. And so, yeah, it looks kind of like a droid or something right now. So a little clamp, a little weight, until that is settled. And just to make sure, the glue probably would have been fine. Is that a tail? That's another culprit that I caught making some stinkies later on in the day. But I figured, you know what? Might as well be safe than sorry. Let's screw these in. That way the eyes are well anchored. Because at this point, I didn't really know how I was going to make the eyes protrude through the furry animal. And for the actual eye sockets, I decided to use PVC pipe. Now, this is a basic. It's not a Schedule 40 or anything. It's just, the kind that you use for liquid. 3/4 inch, I believe, is what it was. And then for the eyes, I just found these really long bolts, drilled a hole right through and decided to attach it that way. Now, the nice thing there is that you can actually move the eyes up and down a little bit in case when you put this contraption in, maybe one eye needed to kind of look down and the other one up, just to get it even. But the holes were pretty much spaced apart. I did minimal measuring. I just kind of like held the thing up and just said, okay, the eyes kind of go over here because I figured this is fabric. We can stretch it out. We can always cut the eye slits out a little bit more if we had to. So this entire project was a big guessing game. Yeah, so if you have any suggestions for version 2.0, I would love to hear them because I think we can do a lot more, make this military capable, I think, for those military grade ones. So I think we can do some cool things, especially with the tail, which we're about to see here pretty soon. But we have the head, we have the eyes, we have the nose, which isn't, moving yet, but we're going to figure that out, and we're going to figure out how to put LEDs into these PVC pipes. And next, what kind of needs a body. And for this, oh, I had to chop its head off first. I forgot about that. Because if you look at FART-A-TUCHUS here, he's actually angled. you know, and that was the toughest part. And here I am trying to get the angle mostly right. You know, I wasn't going for perfection here. After all, this is a FART detector. You know, we're not building, you know, anything going to the moon just yet. You know, maybe that'll be the next project. But I kind of did my best with figuring out what the angle would be. And if I were to do this again, my huge piece of advice is to find like an upright teddy bear. That way you can just, you know, stick it right in and make a simple base for it. And here's another one of those moments where there's just no good way to clamp this stuff. So sometimes you just have to hold it until it dries, you know, mostly. And I don't know if you guys caught the length of that screw. Doesn't it look like it would kind of hit the servo? Well, I got so worried about this, I actually took the whole servo off to see if it crushed through the casing. And it turns out at the bottom of the casing, there was like a tiny dimple. So I missed it by this much. So this poor servo got hammered. It almost got to screw up its derriere, you know, so it's a wonder that it's still functioning. So these little things can take quite an abuse. Either that or it just really loved this mission and it wanted to stay on mission, wanted to know the results. So we have the head, the body, and now we needed to figure out this tail situation because I thought it would be clever to put the sensor here on the end of the tail, and I wanted a tail that would like extend out, you know, so you wouldn't have to like get right up to your subject, because imagine just kind of like walking up to someone and kind of holding a stuffed animal right to their bum. People would know what you're doing, but you can sit there and pretend like you're cuddling it and just go, you know, and then just get your measurements, and then you can see what's going on with his eyes and his nose. So I thought that would be fun, and I had a whole bunch of ideas for how to get this tail to extend. We can use scissor lifts. I even thought of using a series of like toothpicks that would then, let me give you guys a better view, slide out. So his tail would be like all super stubby like this, and then it would just slide out like that, and then slide back in. So I thought we could do this with a servo. Maybe there could be some kind of collapsible rod that comes out. But all in all, I thought that probably the most reliable way to do this was some kind of scissor lift situation. So I decided to build it out of popsicle sticks because I had so many. And so for the tail here, I started cutting up my popsicle sticks. These are about 6 inches in length, but I figured 6 inches would make for a really fat tail, and I wanted the tail to look somewhat natural. You know, it's not like, you know, it's a little fat, but it's not that bad. And so I thought cutting them in half would still give me enough scissor action, enough travel, so I wouldn't have to like hook a whole bunch of them together. And in order to keep them from separating, I decided to use eyelets. You know, obviously I could have screwed them together and you would have gotten that motion, but I thought we still need to run wires to the sensor, and I wasn't quite sure how I was going to handle this. I don't want the wires to get pinched. So one idea I had was actually running the wires through these eyelets, and they're very easy to find. You can find them for leather working crafts, and they come in all kinds of lengths. So I found a length that would be suitable for 2, you know, popsicle sticks. And when putting them together, I only flared the other end very slightly, because if you flare it too much, then it almost like grabs onto the wood and it gives you a lot of friction when you start moving the scissor lift, you know, situation that that I'm creating right here. And also when you use wood, you do get that friction. So the longer you make that tail, the tougher it is to extend. Because one idea I had was to somehow automate this extension, maybe through a throttle cable. One of you guys had an amazing throttle cable idea, or a servo, again, that would extend it for me. But with popsicle sticks, it ended up having so much friction, and then I'd have to hide another servo somewhere. So I decided to keep this manually operated for now, but that idea, I think that's a version 2.0 idea for sure. And then for the tail, I used the natural length of the popsicle stick, and one of my concerns was that length difference, would I not be able to extend the tail all the way? So I did a quick test there, and clearly I was. So putting in my final tail, and I figured that this would be a cool way when the tail is completely crunched in to have kind of a natural taper like you would see on a real buffalo tail, which is not flat like that. But, we're trying to be as real as we can. And also I thought it would be a nice transition for when the tail extended, it would have that nice point. So, I figured I'd do that. Were I to do it again and use the scissor lift, I think I'd do the scissor lift again, but do it with thinner pieces of metal, because that's going to prevent the tail from swaying. As you saw, it's real flexible, which could be a good thing or a bad, because once you extend it, it's almost like, you can kind of bend it to see around corners, if you had to somebody standing around the corner. So the toothpicks or the popsicle sticks are really good for that. So I think all in all, really, really great prototype, but the tail definitely needs improvement, and I most definitely want to put some kind of automated, maybe a switch that you press and the tail just kind of goes in and out. I think that would be super, super cool. So if you have any more suggestions, then post them up. I always read through your comments and put in as many of them as I can into my next versions, into my next builds. So where were we? We have eyes, we have head, we have body, we have tail. Now, I think we kind of need a base, because this thing's going to be awful rickety without that. So what did I do for a base? For this, I decided to give it kind of fake front legs, because obviously we have front legs already, but it kind of needs a way to just be able to stand up. And this probably would have worked pretty well. And there you see I have a handle, and the handle allows me to make the tail go up and down. Somebody is way tall, you might have to bring that tail up, And if it's for a child or someone pretty short, you can bring that tail down to their particular area for proper measurement. So for the base, I just took my great old hacksaw. In the wintertime, I end up doing a lot of my cuts with the hacksaw, and it works out pretty well. If I can use the miter, I try and do that, but when there was 3 feet of snow on the ground, not so much an option. And to cut this slant part here, I thought it was super intelligent to do this in sections, because I figured it'll probably be tough to cut it all the way through in a straight line. So I decided, let me do some teeths, and then I can go tooth by tooth, and I'd be able to kind of fix any imperfections that I had. And this worked out pretty well. Maybe a little bit of crookedness there on that high corner, but after a little bit of sanding, that went pretty smooth. And so it looked like it was just a nice smooth cut. Here I'm getting a little brave, and look what happens when you get brave. It got a little bit warbled, but like I said, a little sandpaper fixes and hides a lot of that stuff. So the most important part with this base is that it can't obstruct the tail, because the tail needs to be able to move up and down. So I made sure to really align this base such that the tail could pass through that groove if it needed to. And I always improvise a couple weights anytime I need to. There's always stuff that you can use. And then I decided to use a screw just on one end of it. The glue is, probably fine on the butt, because there's not much action going on back there other than the tail going up and down. So after that, now comes the sensor wiring, which is at the very end of this tail right here. And I'll give you guys a better look at what I ended up using. So this guy right here, I'm going to zoom on in, check that out. And this is an MQ135 sensor that I decided to use. And for this, and there's a reason I chose this, because when you look at, FART detectors online, you'll see a variety of different sensors that they use with Arduino. And MQ4 is by far the most popular. That's a methane sensor. And so I have that. That's actually what this looks like. And you'll see that it's pretty much very, very similar to an MQ135. Oh, there it focused. So this is an MQ4, and the MQ135 looks pretty much exactly the same. And anytime you buy these, I always recommend to buy the one that's already on the board, so you don't have to create, these little circuits. You can if you want for fun, but for speed of build, sometimes it's a little bit easier to buy it with the board already on it. So why did I go for the 135, which is an air quality sensor? Well, I did a little bit of a flatuous research to find out, what sensor to use, what's the best way of going about detecting farts versus, other things. So it turns out that over 99% of the volume of a fart is composed of non-smelly gases. So 99% of, what comes out doesn't even smell. And the part that doesn't smell is oxygen, nitrogen, carbon dioxide, hydrogen, and methane. So methane doesn't smell. So if somebody is putting out a bunch of methane, it's not like you would even probably know. And for this, you want to be able to detect something when it's going to be stinky so you can run away. Although now saying that out loud, I think I'd want to detect it regardless if it's stinky or not. I'd still want to run away. So that's one of the reasons I didn't go with the methane sensor, because one of the things that I also found out in this research paper I read is that not everybody expels methane. So if you're only using a methane sensor and a whole bunch of sulfur or sulfides come out, it's not going to detect it. And boy, those sulfides, that's, pretty much what makes it stink. And you're going to be like dead in the water. So I decided against the MQ4 sensor, although it's a great one to use. And if you're going to build one, you're definitely welcome to use it, because I think the vast majority of people do expel methane. So you're probably good. But you might, not catch a tiny percentage. So the remaining 1% is what gives it its smell. So like we talked about, the majority of it comes from volatile sulfur compounds. So I wanted something that can catch a lot of the non-smelly stuff, but, maybe catch some of the smelly stuff. So humans fart 8 to 20 times a day, 20 times, putting out 476 to 1,491 milliliters every 24 hours. So it's man, we're like a factory, aren't we? Ugh. That's like having a 2-liter bottle of soda. Oh, that's like, expelling a 2-liter bottle of soda. And farts travel at 7 miles per hour. So at least we can outrun it. The nice thing is that he's going to buy us those first few precious seconds, and we can outrun 7 miles an hour. Like, I'm out of there really, really quick. So an MQ135 sensor registers the following: ammonia, nitrogen oxides, alcohol, benzene, smoke, carbon dioxide, and other natural gases. And I even pulled up on certain data sheets that it does detect some sulfide, so it does have some sensitivity there. But I would like to run an independent test on that one because it was kind of conflicting. But I thought that the MQ135 would be the best bet to be able to really, save ourselves if we find ourselves in this situation where it starts to get stinky really fast. At least you might just lose one half of a face when it melts off, and then, you can at least have the Phantom of the Opera look going. You never know. Fashion always comes back around, and the Phantom of the Opera look might be super awesome. So we have our base, and now we have to wire that sensor. And we both prototyped this together, so we saw how it goes into the Arduino board. But how does it go in real life when you eliminate the breadboard and everything has to go permanently into the Arduino? So this is how I did it. And I started by gluing the sensor to the end of the tail. And all of us, when we were prototyping this, tried to figure out a way to put the sensor on the tail. Do we zip tie it, hot glue gun it like I did, using electrical tape, building a little box for it, and then screwing it onto the tail? I mean, we just talked about a whole bunch of things. But at the end of the day, the tail's kind of fragile and it can't hold a ton of weight. So I figured, a little hot glue. So far it hasn't popped off, and this thing has been put to use. So I think that the was the way to go. And together we had wired this using these connectors that have pins on either end. They're really easy to just pop into your Arduino and pop into the sensor. So I left the pin ends on the sensor and I cut off the other ends, and I figured it'd be easier. I undid all that work that we did together, and instead I ran just a regular hookup wire through the holes. And that way I figured there was going to be a lot less binding from the connections, a lot less failure points, because every connection I'd have to, put a little piece of tape around it to make sure it doesn't separate. So I figured this was kind of, a foolproof way to do it. And anytime I use hookup wire, I try to wire it with similar colors, if not the same. So that way when I have to do repairs months later, you kind of can match up and remember what the heck it is you did. So you'll see here the signal wire coming out of the servo is orange. but yellow is kind of the closest that I had. So I went with yellow. And for shrink tubing, one of the things I learned is to leave all of the shrink tube heating to the end. Because if you start heating one heat shrink tubing, if there's one kind of laying nearby, it'll shrink just enough sometimes that it makes it tough to put it over your connection. And then on the other side of the wiring, I am connecting up the other sides of the pins because these are going to have to hook up into the Arduino. So they're going to need these little pin ends right here. And again, I didn't forget the heat shrink this time, guys. Not like the last time where I forgot it for every connection. Did I not forget it for every connection? Yeah. Thank gosh, thank God you guys were on the stream kind of helping to remind me, like, heat shrink, So you're always a big, huge help. So we have the tail. It is wired. We have these little pins here, and I'll give you a closer look. This is where I cut and I use this little end so that way I can put it into the Arduino directly and connect it there pretty easily. So after that, we got the tail hooked up. I believe now, well, it needs eyes, right? So for the eye wiring, I decided to go, well, for 2 eyes, we're going to need 2 green, 2 yellow, and 2 red ones to indicate 3 levels of fartdom, I guess. Green meaning, all is okay. Yellow meaning, like, listen, you better either crack a window or start running. And red is military, DEFCON 5. It might just be too late for you. And to slip them into the eye, just a little gob of, hot glue there and holding it into place. Those held up, pretty well. And so I did, a green one per eye, yellow and red, and just kind of fed them through and let them sit for a little bit. And for the LEDs, I ended up using, I believe, 220 ohm resistors for them. So at the end, you see that I have a signal or power line coming out of each one, and I basically bundled up all the grounds into a single connection. So I had 3 grounds coming from one eye and 3 grounds coming from another eye into 2 ground pins, for now. Now for these Arduino projects, you can bunch all of the ground ones together and have them go into 1 pin in your Arduino. Because the Arduino, it has a decent number of ground pins, but it's not endless, so sometimes I'll start with more grounds and then I'll start to combine them as I start to run out. So for now, 1 ground for one side, 1 ground for the other, and each of the LEDs kind of have their own signal wire that are going to be hooked up individually. And we will take a look at that here in a second. But once the tail was wired up, the eyeballs are wired up, this is what his skeleton ended up looking like. It looks like a penguin. This does not look like a teddy bear or a bison or anything like that. But you can see all of the red wiring coming from the LEDs hooking up into their proper pins on the Arduino. I used hot glue to kind of organize things as best as I can because this is gonna go underneath the fur. I hooked up a switch for the servo, and here is all of the wiring done for the tail, and you can see the heat shrink tubing where I connected it to the pins that go into the sensor, and my little lever arm there that's used to move the tail up and down. So after that, well, now we gotta stick this thing in here, and I had to upload the code too because I didn't know how much access I'd have to his port back here. See, if we just take his little skin off, you can see the bottom of the Arduino. You can see this port, Ethernet port coming out here, which we also use for power, but also to upload our code. So we kind of prototyped some code the last time, but it's undergone quite a few changes. So let's head on over to the computer and I'll show you kind of what I ended up with to make this whole thing work. So I'm gonna put us on mute just a second so I don't bang the mic, and I'll catch you guys over there. There we go. So hopefully you guys can mostly hear me, And let me just get this, because my head's going to knock into it because that's totally what happened the last time. There was my head likes to knock into everything. So, I got to Darth Raptor there ready to bite my shoulder off. You know, he's like, hopefully you coded this correctly. And so looking at the code right here, and you don't have to know a ton of code. This is not like a code tutorial. It's one of the things that I thought about doing. If you guys are interested in learning how to use Arduino, we can do some simple classes with some fun projects to kind of get us going. And you can see here, the very first line is just to include our servo library. This is just like a whole bunch of information that we can use to have the servo do stuff. So I'm keeping this pretty high level. We're not going to get super deep into the weeds. So this first part, I'm basically telling the Arduino here where everything's plugged in. You know, it's sitting there and it sometimes doesn't know that there's something plugged into it. So I have a left green LED light and I have a green LED right for the right. So basically right and left eyes. And these are where they're plugged in, 13 and 12. Then I have left and right for the yellow and left and right for the red. So each eyeball is being told where they're plugged in. Here we have our sensor, and that's plugged into analog port A5. And instead of reading digital, which is like it's either on or not, well, we want to be able to read a range, right? And so for this, it's best to use an analog port. And for the sensor, we're not reading ppm or anything like that. We're just getting analog values. I really don't need to know what percentage composition is the fart, or to calibrate our sensor to only do carbon dioxide or only do, you know, methane or anything like that. Basically, if the air quality just all of a sudden begins to, you know, stink quite literally, that's all I gotta know. So we kept this analog. Now there are calculations that you can write into the code where it will convert into ppm, and you can use the data sheet to help you out for that. So going through a little bit more of this, here's the little bit about the servo, and I want the servo to start at position 90 because this servo goes from 0 to 180. And of course, you know, our nose is at 90. I didn't want it to start with any kind of crookedness of the nose and give away the fact that there's some machine hidden underneath this stuffed animal. So starting it at 90. And this part of the code that is under this, oh, my mouse is going crazy, a void setup right there, basically tells us how the machine is going to start, you know, right when we turn it on. And so to start, before we start calculating analog values for the sensor, I'm setting up the green LEDs as an output. The pin can either be an input or an output. And by default, Arduino will just say, yep, all the pins are input. Well, you want to make sure you spell it out like, no, I don't want to use this as an input. I want to use it as an output. So for our LEDs, we're using them as outputs because it's going to output the voltage to the LED to light it up, depending on what the sensor reading is. And so, of course, you can see all of the LEDs here are set as output. Now, the sensor is set as an input. Now, I don't have to really put this here because Arduino just assumes that things are inputs. But for me, when I look at this months later, I like to kind of spell everything out, you know, just for my own self. So the sensor is being treated as an input because it's going to read stuff in the air and bring it in. And so we want to collect that data. So it's going to be inputting into the Arduino, which is going to then drive everything else that happens. And so for my servo, now I'm just telling it here that it is attached to pin number 9 right here. And we're going to skip, you know, some of this stuff. We can look at that more in depth, you know, at a separate Arduino tutorial. And here's the loop portion of our code. And that's the portion that just repeats itself over and over and over and over again, you know, until you turn it off. So here, we're just making the sensor an analog read, and this is just for if you want to monitor it through another monitor and actually see the numbers and things, and here where it prints the numbers. Again, we're gonna skip that. That's boring. And for the LEDs right here, basically I'm specifying how I want them to originally start. And so everything you'll see the word low, which means it's not getting any power, means LEDs off until something happens, you know? And so here is when we're specifying what happens and what I want the machine to do, our little animatronics. So if the sensor reading here is below or equal to 400, we're gonna put the green on. You know, things are chilling, there's nothing to be afraid of, the eyes are green, the nose is not moving, so we're safe. Then here, or else if the sensor reading is above 400, so 401, all the way up to less than 500, so 401 to 499, then the yellow LED turns on, both in the left and right eyeballs. And I specified differently because in the beginning I thought maybe I want them to kind of like pulsate alternating or something, but I ended up keeping them the same. And by spelling it out this way, I can always change that later if I just change my mind. So not only do the yellow LEDs now get lit, but stuff starts happening with our servo. So you can see here, we started at position 90. It's gonna go to position 110 by 1 degree increments. And I'm gonna give it 15 milliseconds to do this. So remember, you know, why am I not taking it from 90 all the way to 180? Because that popsicle stick is going to hit the eyeballs. You know, we only have a little bit of room. And this took some trial and error of watching the popsicle stick hit around until I got the movement narrow enough so that way it moves freely without banging into anything. So I found that to be between 110 and 70. So just a little bit of movement. And because the popsicle stick is long, even though it's moving very little over here, the popsicle stick is moving a lot more. Kind of like using a giant breaker bar on a, you know, stubborn nut. Gives you more torque. So that's what happens for the yellow. And so it's moving, you know, 15 milliseconds per turn. It's doing its thing. And then we're going to get to the final situation, which means if none of these situations are happening, that leaves us with one scenario. And that is that the reading is above 500 or 500 and above. So this has got to be that. This is our DEFCON 5 moment. And so you can see here, the red lights come on. And same code that we saw before for the servo, but one difference. And this is our 7 right here. So instead of moving at 15 milliseconds, it's moving faster now. You know, so that kind of, not only are the eyes a visual indicator, but the noses too. So we know that you better start running if you haven't, because remember, that fart's traveling at a speedy 7 miles an hour. So get your feet moving, and you know, and in a shuffling. You know, you don't have to go very fast. So this is our code for our Arduino, and this is what I uploaded and is currently operating the entire thing. So we're almost done with our build. Let's see, you know, the rest of it. And there's not much more to go. So I'm going to switch us back and I'll meet you there. There we go. And I'm going to crawl back. Oh, I tripped over something. Check it out. It's FART-A-TUCHUS stuffing. Oh, yeah. And so this is the stuffing that did not make it back into him. I mean, I guess it could because he still has like, you know, a bit of belly left. But I did put some stuffing back in his belly. But I didn't put any stuffing on his back because that's where like all the wiring is and all that. And I didn't put too much more in his head. So I might be able to. And you'll see our little butt here. Our beanbag butt. Well, that didn't make it back either, you know, because I ended up building the base and, you know, we didn't need it. So keeps him lightweight and functional, you know, keep everything away from the wires. So we got eyes, head, tail. We got the code. The code is uploaded. And, well, we left off that we got to put the endoskeleton into the skin. Oh, that sounds awful. That's another, it puts the lotion in the basket moment right there. And so let's put it in there. Yeah. And this probably was the most cringy part of doing this because I was so afraid of snapping that nose off. Then the whole thing would have to come apart again. And probably the toughest part was getting it around the eye sockets because of that nut on the very outside of the eyes kept catching on everything. And here I'm regretting my decision of not cutting that slit in the back further up. I didn't want to damage the fur. I thought it looked so nice. And if I cut it, it might start fraying, you know, kind of like a sweater. You start pulling the string and the whole thing falls apart. So instead, I just summoned my patience and I just really slowly, you know, and trying to feel for that popsicle stick, making sure it's in the right area and pulling gently down below. But listen, for not measuring, this skin it fit pretty well. It got, I think I got the angle pretty right. And it's not stretched top to bottom because I made it too tall or anything like that. It ended up being pretty good. And I figured erring on the side of shorter is better than longer, because shorter, I can always put extra fur on top and on bottom and kind of position that thing. And the importance of the endoskeleton is now you have a place to anchor the eyes and that servo, because without that endoskeleton, the face would just kind of move like this, and it would just be no rhyme or reason, and it would just look like he's having a seizure rather than sniffing something. So the endoskeleton, although super time consuming, is a necessary part of doing this project. So it's in its skin. Oh, thank goodness. And so it's nice that he's in his skin, but now his tail's kind of showing. So I have to figure out something for doing the tail. But before we get to that, since we are kind of like working with this skin part, is painting some eyes. Like I said, he came with no eyes. My dog completely sabotaged the project and chewed him totally off. So what was I gonna do? Sew on some buttons, or maybe leave the eyes hollow looking into the LED lights? And I thought, well, I can't do that, because that reminds me of those Halloween toys and Halloween decorations that you find at the big box stores. Anytime they have LED eyes, they're, it's just the LEDs that are showing and they shine. It looks kind of like super fake, So I wanted this to look kind of neat, kind of realistic, more realistic, like a toy that you would buy off of a, Toys R Us shelf, if they were still here. I was secretly loved Toys R Us. Always cool geek toys and things there. But I did hit their blowout sale though. So I wanted to do something with the eyes that looked like they were there all along. It wasn't like an aftermarket or happened later, glued on. I wanted them to look like they were sewn on from the factory. So the idea I had was maybe buying glass eyes like this. And so I got these are 1 inch in diameter, and they're just, convex on one side and flat on the other. And I thought, 1 inch, it's a little big. It's a little creepishly big for the size of this, for the size of this animal, especially given his original eyes were like this big. They're really, really tiny. So they look kind of freakishly big when I started, but I figured I wanted something big enough so the LEDs would shine through. And I didn't want to put them just clear like this, because what if you could see the LEDs through them and you would still have that cheap Halloween effect? So I decided I'm going to try and paint them like, doll eyes. And I have never done this. So this is kind of how I went about it. And eye painting. And so I turned them on their backs. And I was going to have the paint show through. And goats, bison, animals from that mammalian family all have those oval type eyes. So I was going to copy that here. And when I started, I had instant regrets. Look how bad that looks. It looks all jaggedy and it's all see-through. But, for this time, I decided I'd persevere. Usually, I just toss it and start again. But I saw that the more layers that I started adding, or the more coats, it started to even out. I started to lose a lot of those jagged edges. And then, of course, as happens with me, I start to get really brave. And this is where I start to use a lot of paint. So a lot of the jaggedy edges are gone. And now I know that I'm going to glue the eyes around the perimeter. And I thought it's going to look really cheap if there's a whole bunch of hot glue around the eyeballs, and they're going to look really bad. So I need a way to conceal them. So I thought about darkening the outer perimeter that would hide the glue line. And so using a flat brush and just dry brushing, I'd start from the outer edge and just push that paint towards the inside. And what started to happen is, if you think of somebody's iris, it's got natural striations. So it started to create these cool natural striations. And I was like, well, how fortuitous. This thing that started out all scary is actually starting to look pretty good. And at this point, I thought I was done. This is going to look really super cool on FART-A-TUCHUS. But then I thought, would you still be able to see the LEDs, and would it glow like way too bright and basically reflect off the glass eye? So I thought maybe I should paint it a color, but translucently, so that way my LEDs could shine through. Well, every color I thought of was going to clash. Blue, green. I couldn't use green, yellow, or red, And so I thought it's just going to mix up the colors. So I decided to go with a metallic, and that's where you see this gold, so either gold or silver. And the advantage of a metallic is that it's actually pretty translucent itself. Any metallic paint, you're going to have to add more layers because it's naturally just not, the pigmentation is not as plentiful as with your solid colors. So that was the way to go. And although it looked like there was a lot of color going on sometimes, I kept flipping it over just to make sure that, and holding it up against the light that you can see enough light coming through it. So all in all, I think it looked, pretty good. Couple jagged edges. The pupils, might have been able to be, smoothed out a little bit. But by the time you put it on, and also when you turn it over, a lot of those imperfections are gone. They're really visible on the back side, but on the other side, looks pretty good. So we have our eyes, and now we have to actually get them on him. And this was pretty messed up. So I have to push the PVC pipes through his fur, and I want to be real careful not to get glue and just mangle up all that fur area. So I took my skinniest little nozzle and slowly just added dabs of glue and held the fur in place so that way it would be stuck to just outside of that PVC pipe. That way I can glue the eyes on the PVC versus gluing it on the fur. And what I found is that 3/4 inch PVC, the outer diameter is pretty close to 1 inch. So I'm like, okay, this is all working out for someone who did no measurements and just started putting this together with pretty much no plans. And so this is what he looked like when all the gluing was done. Very Halloween creepy. Imagine those lights coming on and oh, that glue just doesn't look really good. So here I'm putting the glue on the outside of the PVC, just that outer surface, to be able to glue the eye on. And let's see if my idea worked. Hey, you can't really see any glue lines, and I am super surprised that I didn't get glue all over his fur. It's always the tough part when you're done hot glue gunning and you're pulling the gun away. It always leaves that string. Is that eye crooked? Oh, I think that eye is kind of crooked. But you know what? I am not going to fault him because if you're about to smell farts all day, listen, I'd be like cross-eyed too. So I'm going to let him pass on the eye crookedness there. It's, barely visible. So it's maybe it crooked the other way after detecting various smells. And so I had fun testing him with alcohol, with basically everything on the list that I can find to see how sensitive it is. And that's what helped me put these numbers together. And these numbers are going to be different for different people because if you put, if you got friends that are putting out, the really bad military grade, they have to carry a permit, for what they're putting out, you might want to make this thing less sensitive because any little thing is going to set it off. If you have people that it's barely noticeable, you might want to make it more sensitive. So it's a little bit of trial and error with the code to get it reading in realistic, ranges. I didn't want to put it in a range where no one would be able to attain a reading because that's half the fun is figuring out who can, set it off the most. So we have our eyes, and finally we got a naked tail. So we gotta take care of concealing this extendable tail situation. Now, me, by any stretch of the imagination, I am no seamstress. So I am just kind of I can run some lines in the sewing machine, but that's about it. So I started by figuring out what width I'm gonna need when the tail is fully collapsed. And then what length I need when the tail is fully extended. So here I'm trying to pull it out as much as possible. Careful, don't break it. And figuring out how much fabric I'm going to need there at the end. So I cut it way long, just in case, because this is the only tiny piece I was digging around that I have. So in order to calculate the I guess taper, I figured, start with it fully contracted and then pull it out and draw a line to the tail. Now, there's no scientific way of why I did this or reasoning or anything like that. I figured I'd try this first before doing very complex measurements. And if the tail stays within these boundaries, I should be good. Theoretically, I should be good. And so it looks like, with the movement, I'm not really coloring outside the line. And I start sewing this thing together. Now, any of you who have ever sewn, seamstresses, are looking at this oh my gosh, look at this setup. Oh. The sewing machine is backwards. Why is the sewing machine backwards? Well, one of the things that I've learned in shooting videos is I've learned to do a ton of things backwards because oftentimes the camera view is best, looking in front of you. So normally that machine would be turned around and I would be feeding it, towards you guys like this. But putting a camera between you and the object causes like banging around. You never really get great footage. The lighting is horrible because you're hovering, you know, over it. So I've learned to do a lot of things backwards, soldering included, where you're soldering completely away from you and you're just hoping for the best. So I sewed it inside out and I flipped it right side out. You know, right side out. Yes, I guess that would be the term. And slipped it over his tail. So, you know, it worked out pretty well. I cut it a little bit roomy for the width, so that way the tail has room to move. The wiring isn't going to bind up against the fabric. And I wasn't going to permanently attach the fabric to the tail. I want to be able to like rip it off like a glove. And so it's got Velcro where it attaches to his butt here, and this part here has some Velcro right there that attaches to this fur. For whatever reason, this Velcro loves this fur, and it attaches really nice and really, you know, you can't really tell. It's all nice and seamed up. So it doesn't look butchered or anything. So that was for the tail, and it extends pretty nicely. It doesn't bunch up. You know, you get your collapsibility and then you get your extension, and you can see how much fabric is left. So it's not too bad. I even thought about maybe, you know, sewing where the eyelets were so the fabric doesn't like move around. But if I sew where the eyelets I can't pull this off very easily. I'm going to have to remove every little sew point. Oh, and that's, you know, the tail that can go up and down. Oh, I'm mashing the sensor there. But yes, you see how it wiggles? I probably would do this out of metal. But I don't know, it might be an added feature, you know, if you need to have it see or smell around corners. So at the end of the day, we have our tail and he is completely put together. So now, you guys want to have a little fun? Let's see what he's made of, right? So the way I'm powering this is like we prototyped before. You don't want to power or try not to power your servo off your Arduino, because the Arduino is powering the eyes, the sensor, and a micro servo. Listen, between you and me, you could probably get away with that. Like somebody else will say, oh, you don't power the servo through the Arduino. Now, real servos, yes, micro servo, you can probably get away with just for fun and testing. I would not make it part of a final project at all. So I treated this more in that respect as a final project. And the servo is being powered by this 4 AA battery pack right here. And I have a little connection for him. Probably sitting on it. So I'm going to turn him around, maybe give you guys a better view here. And if I turn him around, you can see here, now the battery is made to go inside this foot right here. And so we can get him hooked up, but let me get the eyeballs hooked up first. Actually, no, I'll do him. These little clasps are kind of hard to get on, this clasp right here. There we go. And hopefully I didn't pull out any wiring. And now, coming out of the Arduino, let me just back this. Let me back him up a little bit so you guys can see what I got going on. Move these eyelets, and this is the battery that I'm using to power the Arduino. And this is your typical like phone charger battery. They're really great for powering these things. They're, you know, inexpensive enough that you can buy a 2-pack and buy a couple of them and just keep charging them up for fun. And so this guy will go down here in his foot. Yeah, so he's right here. And this guy, move him here, will go in this foot right here. But we're going to leave him out. I'm just going to leave him out. And now anytime you plug in your, you know, your situation here, especially with sensors, they do need to warm up for like 2-3 minutes. And so you'll see it kind of go haywire, lights going, all that kind of stuff for a bit until it warms up. So this is not something where like you smell something and you turn it up, you know, and you want to try and find who it is. You have to kind of like plug it in first, let it warm up, and then do the testing. So you want to do this, you know, prior to the suspected toot. And then just leave it on. You can change the batteries as the day progresses. But here he is. And all I'm doing is plugging this into here. Let's see what happens. So wake up, and you can see his eyes are green. Now, that wasn't me. Stop it, guys. That was not me. That is actually the sensor firing up, even though it's located here. But I swear it's not me. It's not me. This is what happens when the sensor is warming up. It's cycled through the red. You can see that it's moving very quickly. That's our 7 millisecond. Now it's beginning to go into the, as those numbers are coming down, anytime you turn on a sensor, it starts really high. It's like, holy crap. And then the numbers start to move down, down, down into our scales that we created. And now it's in the yellow. Eventually it'll get to the green and it'll chill out. And now it's in the green, so you can see the green eyes. I know it's kind of tough to see with the light, the color of the eyes. But you can see the eyes are kind of big for his head. And one of the things I did have to do was the eyes of the original animal were like, why am I crooked? They were more inset. And so the PVC pipe was like way out here. So I had to slit from the original eye holes out to be able to like kind of stretch the fur that way. So it was slight miscalculation, but for not measuring, it's pretty good here. And so we have it green. Let's see if we can set it off. And I'm just going to take its tail right here and maybe blow on it. I'm going to put some carbon dioxide on it and see what happens. All right, so my carbon dioxide gets it going like to the yellow. Let me see if I can get it going a little more. I got it to the red. All right, so a little carbon dioxide. It's pretty sensitive to that. And the other thing I have on hand is rubbing alcohol. And just by wafting, and you can use the real thing too, test and party at the same time. So I'm just gonna take this and squeeze the bottle and just waft some of that vapor onto the sensor. See, that's really sensitive to that. Immediately that thing starts going. And see, it's doing the very fast 7 milliseconds. And I'm just, continually wafting it on there. So this project was a ton of fun. Oh my gosh, I just feel like building a few more of those. And when I started putting up the first videos, people were actually asking me, where can I buy one? Where's your Etsy store? So I don't know. What do you guys think? A line of FART-A-TUCHUS's on an Etsy store? What do you think? A Gearhead Diva store with FART-A-TUCHUS's? I don't know. I might have to, think of other animals to kind of hide them in. So let's see here. These two, they've been watching the whole time. So don't be laughing. Don't be laughing, because you could be next. Well, thank you for joining, guys. I had a ton of fun with this project, and I had a ton of fun with you guys. And again, keep posting your suggestions. We're going to hop on Discord next week to discuss the future project. And I'd love to pick your guys' ideas on direction for that. What cool features do you want to add? Because a lot of the ideas for these things come from you. I'll usually throw out kind of like a base idea, and then you guys are super great at coming up with like, oh, now add this and add that. And it really gets me thinking and become inspired by your ideas. So thanks again for joining. Have a great night. And until the next fun project that may or may not involve you two, depending on your behavior, catch you guys next time. And thank you so much for being part of the Wrench Army. It is because of your support that we can have a lot of fun like this. So catch you guys later.